In this video, we're going to look at the structure and properties of ionic compounds. Ionic compounds don't form molecules like some covalent compounds, they form giant ionic lattices, as shown here in the picture. A giant ionic lattice is a regular arrangement of ions in a repeating pattern, and this is three-dimensional. As an example, we're going to look at the structure of a sodium chloride crystal. Now, as you can see, the structure is a 3D giant ionic lattice, but for the convenience of this video, we are going to only look at it in a two-dimensional field of view. Now, it's made up of positive and negative ions. The positive ions are the sodium ions, and because of the positive ions, we call them cations. And the negative ions are called anions, and in this example, they are the chloride ions. These are held together very strongly by electrostatic forces of attraction. Now, these occur between positive and negative ions because oppositely charged ions are attracted to each other. These attractions are called electrostatic forces of attraction. Electrostatic forces of attraction are ionic bonds, and they are very, very strong. Due to the electrostatic forces of attraction between the ions being very, very strong, ionic compounds have a high melting point and a high boiling point because a lot of energy is required to overcome these strong forces of attraction. In the diagram, we have a battery and a light bulb connected to solid sodium chloride. The light bulb would not turn on because solid sodium chloride does not conduct electricity. It does not conduct electricity because the ions are not free to move and carry charge. In a solid, they are held in fixed positions. Therefore, solid ionic compounds do not conduct electricity. If we connect the same circuit to a molten ionic compound, then the light bulb will illuminate. This is because the ions are free to move and carry charge. Because as a liquid, the ions can flow over and around each other. Therefore, molten ionic compounds can conduct electricity. Similarly, ionic compounds that are dissolved in water, which are aqueous or in solution, can also conduct electricity because the ions are free to move and carry charge. Which would have a higher melting point and boiling point, sodium chloride or magnesium oxide? Sodium chloride is made of sodium ions, Na+, and chloride ions, Cl-. Magnesium oxide is made of magnesium ions, Mg2+, and oxide ions, O2-. As you can see, sodium and chloride ions have a smaller charge than magnesium and oxide ions. The greater the charge on the ions, the stronger the forces holding them together. So magnesium oxide has stronger electrostatic forces of attraction and therefore require more energy to overcome these. So magnesium oxide has a higher melting point. The melting point of sodium chloride is 801 degrees Celsius. The melting point of magnesium oxide is 2852 degrees Celsius. Now I want you to pause the video here and try these 5 questions about giant ionic structures. Here are the answers. Like the video if you got 5 out of 5.